Hi and welcome to the segment of Quick Math about transformation. Transformation is an operation that repositions, resize, and/or reflect a point or object. This segment will only cover translation, reflection, rotation, and enlargement. Let me start off with translation, which is a transformation, seeing the movement of all points of the object in the same direction and by the same distance as defined by a vector. The shape and size of the object will remain unchanged in a translation. The diagram shows some examples of translation. A becomes B when translated along the vector 9, 0. A becomes C when translated along the vector 14, 13. And A becomes D when translated along the vector -5, -2. We shall now perform a walkthrough for a translation along the vector 9, 8. Step 1. Label all points representing the corners of the object in a numeric order. Step 2. Translate point 1 in accordance to the given vector. In this case, 9 grids to its right and 8 grids higher. Step 3. Repeat step 2 for all other points in succession, namely points 2, 3, 4, and 5. Step 4. Join all the translated points in accordance to the numeric order. Next, we have reflection. This is the transformation that moves all points of the object by the same perpendicular distance behind the mirror line. The shape and size of the object will remain unchanged in a reflection. The diagram shows some examples of reflection. A becomes B when reflected against the mirror line x equals 1. A becomes C when reflected against the mirror line y equals -x. And A becomes D when reflected against the mirror line y equals -2. We shall now perform a walkthrough for a reflection in the line y equals -x. Step 1. Draw the mirror line. Step 2. Label all points representing the corners of the object in a numeric order. Step 3. Reflect point 1, ensuring dotted line is perpendicular with mirror line y equals -x, and red point is the same perpendicular distance from the mirror line as this distance for the blue point. Step 4. Repeat step 3 for all other points in succession, namely points 2, 3, 4, and 5. Step 5. Join all the translated points in accordance to the numeric order. Next, we have rotation. This is a transformation that moves all points of the object by the same rotational angle from its center of rotation. The shape and size of the object will remain unchanged in a rotation. The diagram shows some examples of rotation. A becomes B when rotated 90 degrees anticlockwise about the center 0, 1. A becomes C when rotated 180 degrees about the center 0, 1. And A becomes D when rotated 90 degrees clockwise about the center 0, 1. We shall now perform a walkthrough for a 90-degree clockwise rotation about the center 6, -2. Step 1. Plot the center. Step 2. Label all points representing the corners of the object in a numeric order. Step 3. Rotate point 1, in this case at 90 degrees clockwise about the center 6, -2. Step 4. Repeat for all other points in succession. One simpler way of doing this is to plot the object on a separate piece of paper. Then rotate this separate piece of paper by 90 degrees to provide you with a sense of where the points 2, 3, 4, and 5 should be. Step 5. Join all the translated points in accordance to the numeric order. In our fourth and final transformation of this segment, we have enlargement. This transformation positions all points of the object by a scale factor from its defined center. The size of the object will change in accordance to its scale factor, but the shape of the object will remain unchanged in an enlargement. The diagram shows some examples of enlargement. A becomes B when enlarged by scale factor 2 from the center minus 10 minus 7. A becomes C when enlarged by scale factor 3 from the center minus 10 minus 7. And A becomes D when enlarged by scale factor 4 from the center minus 10 minus 7. We shall now perform a walkthrough of an enlargement by scale factor half from the center 10 minus 5. Step 1. Plot the center. Step 2. Label all points representing the corners of the object in a numeric order. Step 3. Scale point 1, in this case by a scale factor of half from the center 10 minus 5. Step 4. Repeat for all other points in succession. Knowing that the length of all sides in succession will also change by the scale factor of half, we can plot points 2, 3, 4, and 5 accordingly. Step 5. Join all the translated points in accordance to the numeric order. Tutorial Walkthrough 1. Identify the center and scale factor of the enlargement from A to B. Begin by plotting two lines across identical corners of the two objects in the diagram. The center is the point of intersect of the two lines at the coordinates 0, minus 5. And as for its scale factor, this is the ratio in size between the image and the object, this being half for the question. Tutorial Walkthrough 2. Identify the center of the 180-degree rotation from A to B. Begin by plotting two lines across identical corners of the two objects in the diagram. The center is the point of the intersect of the two lines at the coordinates minus 1, 1. Tutorial Walkthrough 3. Identify the center of the 90-degree rotation from A to B. Begin by plotting two lines across identical corners of the two objects in the diagram. In this case, you have to additionally plot the bisector of these two lines. The center is the point of the intersect of the bisector line, and this being the coordinate 1, 0. That's all for this segment. Do visit our other segments of Quick Math if you found this beneficial. Bye bye for now.